Today we'll see the data types related to this Verilog. Okay, data types in Verilog. So basically, what is data type? Do you have idea? Any idea? What is data type? Hmm. Basic data types in Verilog. Okay, data types in Verilog. Okay. So data type is nothing but it's a classification that tells a computer what kind of value a variable holds. Okay, so it is nothing but data type. Okay, how the variable will be stored. Okay, in C language, you already seen no like int, char, okay, float, like that. It is some types of classifications are there. Okay, so in the data types you have classifications. Classification that tells okay, that tells the computer. Okay, tell the computer what kind of value the data should store. Okay, what kind of value, what kind of value a variable holds. Okay, variable holds, and what type of operations can be performed on the value. Okay, what type of operations, what type of operations can be performed on the value, can be performed on the value. Okay, so that means it can be int data type, float data type, like that. You have different types of data type. First data type in the Verilog is net data type. Okay, net data type. So what is this net data type? So net data type is used. This is net data type. This is used for physical connection. Okay, only used for physical connection. Okay, and so this is used to store. This is used to drive the value continuously. Okay, from the driver. Okay, this is used to uh, drive the value, drive the value continuously from the driver, from the driver. Okay, uh, so main important thing is by using this net data types, these are not for storing the values. Okay, these are not for storing the values, storing the values. Okay, suppose so in this you have wire data type, wire, war, and WAN. Wire, war, and WAN. Okay, wire, war, and WAN. Okay, so here let us take one example, module example. Okay, if I consider wire A. Okay, wire A. This is nothing but this is the data type. This is data type, and this is variable or identifier. Variable or identifier. Okay, okay. So here if you see the net data type, let us take this is module A and this one is module B. Module B. So module A is connected to the module B. Okay. So this module A is driving some value. Okay. Suppose it is driving some value. Let us take that that value is stored. The value is represented in the variable A. Okay. This is driving some value. That value is received by module B. Okay. So that A value it is driving to the module B. Okay. So in this situation, what you are doing, you are using net data type. Okay, so that means this is not used for storing any value. Okay, this net data type not used for storing any value. Okay, storing any value. Okay, so we should connect with the net data type. Okay, for driving some value, we need to connect with the, this net data type. Is it fine? Do you understood? Okay. So what is the default value for net data type? Default value for net data type. We already see in the value set, no? Value set. Value set. Suppose if you consider wire A, okay? So wire A. So what is the default value? It can be default value. Huh? You are saying something? 0, 1, x, z. Okay. In this values only that value will be there. So the default value is what? High impedance. That is not connected. Okay. What is the default value? It's a high impedance. High impedance we already seen, no? That is special character, special symbols we seen, no? Not connected. Okay, not connected. Okay. So this is the default value. And if you write wire A, this is of how many bit? Tell me. This will store how many bit? This will store only one bit only. Okay, it will store only one bit. Okay, it will store one bit only. Okay. So here if you see, uh, so uh, let us take one example. Module example. Okay. I'm assigning with wire data wire A. Okay. Assign A equal to 0. Assign A equal to 1. Assign A equal to 1. If I want to display $display the value of A is percentage D comma A and end module. Now tell me what is the value of A? I told you Verilog is which type of language? Verilog is which type of language? Verilog. Verilog is a concurrent language, no? Concurrent or parallel language. Parallel. So parallel means parallelly it will execute. Okay. So these two instructions will be executed parallelly. Okay. So two instructions will execute parallelly. Okay. So after executing this, you are getting the output. Compiler can't decide to store the value a equal to 0 or a equal to 1. At last, what you will get a equal to x. Do you understand? Okay. And suppose for the var data type, same example you take. Okay. Module example, module example. I declared with which data type? Var A. Okay. I am assign a equal to 0 and assign a equal to 1. I am displaying. So dollar display the value of a is percentage b. You can write the format specifier as percentage b and end module. So now what is the value of a? Tell me. Var var. No, or war. In the name itself, it is there. It will do which operation? Or operation. Oh, so 0 or 1. What you are getting? 1 you are getting. Is it fine? Do you understand? It will do the or operation. Or operation of 0 and 1. What is the output? 1 bitwise OR operation. We will discuss the operator separately. We will do the bitwise OR operation. Suppose if you are representing VAND A, now tell me the what is the output? 0 and 1. 0 and 1. What is the output? So A equal to you are getting 0. If it is VAR, A equal to 1 you are getting, and if it is VAND, A equal to 0 you are getting. Okay. So do you understood? Is it fine? Okay. One second. Yeah. Have you installed this Xilinx Vivado? I shared this video. Installed? Okay. Okay. So just one second. Mm, mm, okay. Here, if you see, GVim also you installed, no? GVim. AMD okay. One more software is there. That is editor window. That is free only. That is GVim. Okay, just to Google it. So that is a GVim download. This is GVim download. Okay, so you can download. This is free only. So this is one of the editor. So you install 64-bit installer. This is installer is there, no? So I will share some codes related to whatever we discussed that you can open in the GVim. Okay, okay. So this is one example related to wide data type. We will see. This is the wide data type. Okay. If you see the wide data type. Okay. So in the GVim there are like two options are there. When you press escape, that will go to the command mode. When you press I, that will go to the editor mode. Okay. Okay. Command mode means some commands are there in the GVim. So if you want to edit, so just I press I, it will go into the editor mode. Okay. So this is the code for the wire data type. See here, module wire example wire A comma B comma C, assign A equal to what? One tick binary one. Means A is driven by the constant one, and assign B equal to one tick binary 0. B is driven by the constant 0, and I'm assigning C equal to what? That is I'm doing bitwise AND operation A and B. So 1 and 0 means what you are getting the output? 1 and 0, 0 no? 1 and 0. So if you want to display initial begin hash 10, okay, hash 10 is nothing but delay you are giving, dollar display, A equal to percentage B, B equal to percentage B, C equal to percentage B. These are the format specifiers, and A comma B comma C, end and end module. Okay. Did you understand this code? Okay. So here what you need to do here. So I will tell you the process how to execute this. Okay. One second. Yeah. Hmm. So you need to open this Vivado. Okay, Xilinx Vivado. In EDA playground also I will show you how to execute. Before opening this, I will tell you in the EDA playground. EDA playground is a open source. This is open source software. Okay, open source tool. Okay, we call it open source tool. What you need to do means you need to register with your mail ID. Okay, in EDA playground, you need to register with your mail ID. It's taking time. It's taking time. One second. So EDA playground. EDA playground. Yeah. So here EDA playground is there, no? So you can start with your Gmail. So here I already registered. That's why I'm signing with this Gmail. Okay. So here you need to write the design code, and here you need to write the test bench code. Okay. Right side design code and left side test bench code. Okay. So here whatever the code I wrote, just I'm copying this. Select all, copy, and I want to see this output in the GBM. GBM. Okay. So here I am writing the design. Okay. Test bench we not yet started. So when you write the test bench, I will tell you. Okay. So after writing this code, go to tools and simulators. Select the languages are test bench, system Verilog or Verilog. That is for test bench and design. System Verilog or Verilog. Suppose if you are going for UVM means you need to select UVM. This is 1.2 you need to consider. Okay, UVM 1.2 you need to select when you are using UVM. Okay, that time we will do this. Okay, tools and simulators you need to select Aldec Rivera. Okay, Aldec Rivera and save this file and run this file. So what is the value of A? 1, B is 1, C is what? 0, no? Okay. Suppose if you comment this, okay, single line comment, as I told you, assign A equal to 1 tick binary 1, assign B equal to 1 tick binary 0. So dollar display, if I want to execute, what is the value of here what I will do? I will give A only. Okay. So what is the value of A when you display? Don't care now. Yeah, don't care. X. Yeah, X. When you run this code, so A equal to X you got no? Have you seen this? A equal to X. Okay. And if you represent with the var, what is the value of A? 1. Yeah. A equal to 1 you have to take. Okay. If you declare with wand, what is the output? A will be 0. A will be 0. So have you understood this? Okay. Yeah, this we can run in the Vivado also. So I'm open the Vivado. So go to the project, new project. I need to create the project. Okay. So here project name is, I'm giving the project name as data types. Okay, I'm giving the project name as what? Data types. Okay, data types, and you need to means uh, you need to remember the location where you are storing your programs. Okay, so where I'm storing means I created one folder in the this D drive only, where, yeah, Navin Malaysia, and this one RTL codes using Xilinx Vivado. I created one file. Okay, so I created one folder RTL codes using Xilinx Vivado. Okay, so from from now onwards, what I will do, whatever the codes I am writing, I will store in this folder only. So now in Malaysia, RTL codes using Xilinx Vivado. Okay, so Vivado. Okay, Xilinx Vivado. Select this folder, and next you need to create a what type of project? RTL project. Okay, RTL project. Next, you need to create the source. Okay, so what is my source? Project is data type. For sources, I am writing for what? Wire data type. Let us take wire underscore data type. Wire underscore data type. Okay, so in the location, you need to choose the location. So in this I created data types. Okay, this is my data type. Select this folder. Okay, and next, constraints are optional only. This is no need to give. And next default. This is nothing but this is part number. Okay, this is nothing but like for FPGA. it will give the part number. By default, it will select the part number, the part number, and how many IO pins available, IOBs, input output blocks, LUTs, lookup tables, flip flops, RAM blocks, like this. It will select the FPGA board. Okay, FPGA, whatever the FPGA is there, that will select. Okay, so that is default part. Okay, and click on next and finish. Okay, module name is also I'm giving same name. Okay, yes. So my source design source is created. See here, my design source is created. Okay, so this whole thing is not required. Just delete this. Whatever the code I wrote in the this one, just select and copy and paste here. Okay, paste here. Save this code. Save this code and run simulation. Run behavioral simulation. Run simulation. Run behavioral simulation. Now you see. Now you see what is the value of A in the TCL console. You are getting the output. A equal to 1, B equal to 0, and C equal to 0. No, 0. Okay. So same thing. Whatever I explained in EDA playground, I am commenting this. I am changing the value of A equal to 1 and A equal to 0. And if you want to relaunch the simulation, this symbol is there. Okay, any changes you are making in the code and you are in the simulation, if you want to relaunch the simulation, you need to use this symbol, relaunch the simulation. Okay, so I am saving this code. What is the value of A? X. Assign A equal to 1 and assign A equal to 0. No, next I am displaying, and displaying means what? Displaying means it will execute x only. No, okay, x only. Okay, next I'm declaring this word data type. Okay, when I'm declaring with word data type, again relaunch the simulation. Okay, A will be 1. A will be 1. Okay, again wand. Okay, next relaunch the simulation. Save this. A will be 0. Yeah, do you understood how to? Suppose if you want to come out from the simulation, just close this simulation. It will come out from the simulation. This is the interface. Did you understood? Okay. Yeah, this is my Vivado. This is my GVIM. Okay, this is EDA playground. Okay. Next, we'll see for next data type, that is reg data type. Okay. So wide data type is fine. No, any doubts or queries? Okay. Yeah. So next, you see with we'll see with reg data type. Okay, what is this reg data type? We'll see. Okay, reg data type. Okay, so reg data type, by using reg data type, we can able to store the data. Okay, we can able to store the data. Store the data. Okay, we can able to store the data. Okay, uh, let us take one example. Module example. Okay, uh, I am declaring with reg A. Okay, uh, so if it is reg means you need to use this initial block. You need to use these procedural blocks. You need to use. Okay, initial, and I am giving A equal to 0. Okay, so end module. Okay, Suppose if I want to display this value, so here what I need to do, so multiple statements are there means you need to write between the initial, begin and end block. Okay. So I am giving a equal to 0, dollar display. Single statement means no need to use begin and end, but multiple statements are there means you need to so write begin and end. The value of a is percentage b comma a. Okay, end module. Now what it will do? It will storing the 0 in the variable a. We are storing 0 in the variable a. In the variable a. Okay, a variable a. What is the default value? Default value. It may be from these values only 0, 1, x, z. Hmm. Default value is x. Default value is x. Don't care. Okay. So the value can be either 0 or 1. No, when you are like initializing, so reg a. So reg a means the value can be either 0 or 1. Okay. Uh, so if you take reg a int reg a and initial. Okay. Let us take initial reg a initial. I am giving a equal to 32. Okay. What is the value of a? Reg a means how many bit? 1 bit. No. 1 bit. Reg a. Wire a. Initially I told you no. Wire a means how many bit? 1 bit. 1 bit. Reg a is also 1 bit only. Okay. But here you given 32 now. So normally what it will do? It will convert into binary. So 1, 2, 4, 8, 16 and 32. Okay. So this is 1. Remaining all are zeros. No. So whatever the LSB bit is there, this is LSB bit, no? This LSB bit will be stored in A. A equal to what? 0. Okay. So least LSB value will be stored in A. So LSB is nothing but least significant bit. Yeah, least significant bit. Okay. So this is about the reg data type. Do you understood? Any doubts or queries? Okay. So we'll see the reg data type. Yeah. So Y data type is completed. If you see the reg example, okay, reg example, yeah. If you see module reg example, reg x comma y comma z, initial begin, x equal to, I'm assigning with one tick binary a1, initial begin. Okay, I told you no, when there are multiple statements, you need to write, so you need to use the procedural blocks initial and you need to write between the begin and end. Okay, this is begin and end. Okay, this is begin and end. X equal to one tick binary 1 and y equal to one tick binary 0 and z equal to, you are using this XOR operation. Okay, so bitwise XOR operation, x equal to z equal to x XOR y, XOR operation. So after 10 time units, data display x equal to percentage b, y equal to percentage b and z equal to percentage b, x comma y comma z, end and end module. So 1 XOR 0, what is the output? XOR operation, AND gate, sorry, XOR gate, XOR gate. Define XOR gate. No, no. XOR gate is nothing but odd detector. If odd number of inputs are there, you are getting the output as 1, no? Okay, that is odd detector. If same inputs are there, 0 0 means 0, 1 1 means 1 1 means what? 1 1 means 0. So for different inputs 1 0 or 0 1, you are getting the output as what? 1. Okay, so you should get z equal to 1 1 you will get. Okay, so that I will check. Okay, so select all, uh, copy, and see in the EDA playground. First I will see in the EDA playground. Where is EDA playground? Here EDA playground. So paste here, save this and run this. X equal to 1, y equal to 0, z equal to 1. You got. Okay. In the in the VBAD, how I need to see means, here add sources are there, no? Here plus sign is there, no? You need to add. Okay. Add or create the design source. I need to create the design source. Create file. Okay. I am creating this file. What is my file name? Reg underscore data type. Reg underscore data type. Okay. And you need to store this your code in the data type file. Select that. Okay. Okay. And finish. And module name also same thing I am giving. Now my reg underscore data type is created. Okay. My design source is created. Okay. So this file I'm copying. Okay. Copy, and here you remove this, not required. Just paste. Okay. Save. What happened? Run module. Okay. So here if you want to see the simulation, in the simulation sources you need to set as top module. Reg data type you need to set as top module. Okay. Top module. Run simulation, run behavioral simulation. Now what is my value of x, y, z? X equal to 1, y equal to 0, z equal to 1. Okay. So whatever you are simulating in the simulation sources, you need to right click and you need to set that module as top module. Do you understood this? Understood. Okay. So next we will go with vectors. Okay. So Regia and Viria is how many bit data? It will store how many bit data? 1 bit data. Okay, 1 bit data. If you want to store multiple bits, okay, you need to go for vectors. Okay, okay, vectors. So what is vector? So what is vector? Vector is nothing but vector. Okay, vectors. Vectors is grouping the multiple bits into single variable. Single variable. Okay, grouping of multiple bits into single variable. Single variable. Okay. We already seen the vectored mux, no, in the digital. Have you remembered? Okay, vectored mux we seen. Okay. uh, so what is the syntax? Syntax is data type, data type, and next range and a variable. Okay, data type you can use reg or y data type. You can use reg or y data type. Data type. Range is so one is MSB down to LSB. LSB down. This is nothing but down. Okay. And next or LSB to MSB. Okay. Up, yeah, this is 2. Okay, so mostly we'll not use this, we'll use only this. Okay, MSB down to LSB. Okay, MSB down to LSB, and anyway, this is variable. Variable you can initialize with A or B or X or M, any variable you can replace. Okay, this is the syntax for vectors. Okay, shall I move forward? Okay, yeah. Suppose if you want to store uh, some 3-tick binary 0 1 1. Okay, so how to write by using vectors? Module, example. Okay, example, reg. How many bits are there? 3 bits. 3 bits means what? 2 down to 0 A. Okay, 2 down to 0 A, initial, begin. Okay, A equal to, I am declaring A equal to 3-tick binary 0 1 1, and dollar display. Okay, I want to display dollar display the value of A. The value of A is percentage B comma A, end and end model. So like this you can store 3 bit of value. So how it will store means, like this it will form horizontally, 3 locations will form. So 1 1 and 0. So this is index 0, index 1 and index 2. Do you understood how I can store the 3 bit value? Okay. Suppose 4 bit data is there. 4 bit data. 4 bit data if you want to store 4 bit of data. 4 tick binary 0 1 1 1. Okay. But same code I can write here. Here how I can represent the reg down to 0 A. Okay. So it will store like this. 4 locations it will form 0 1 1 1. Okay. So index 0, index 1, index 2 and index 3. Okay. So reg 0 to 3 A. Okay. So we are not using this, no. This is LSB to MSB. This is LSB to MSB. I told the range we are not using. So we are using MSB down to LSB. We are not using LSB to MSB. Okay. Hmm. Suppose wire 31 down to 0, I am declaring like this. So how it will store? 31 means 32 locations will form. So 0 and this is index 1 and this one is 30 and 31. Okay, like this it will form. Is it fine? Okay, so we'll see one example related to these vectors. Okay, uh, have you understood any doubts or queries in this? Okay, okay. Hmm. So examples, yeah, examples. When you go to the examples, you can understand. Okay. Mm, this is vectors and arrays. Vectors. Okay. See here, module vector example. I'm declaring reg 7 down to 0 data. So that means I'm declaring how many bit of data? Data with how many bits? 7 down to 0. 8 bits, no? 8 bits. Okay. Wire 3 down to 0, nibble. I told you, no, like nibble means what? How many bits? 4 bits, no? Nibble means 4 bits. So 3 down to 0, nibble I am declaring. I am using assign nibble equal to data of 3 down to 0. Okay. So that means nibble equal to, from these 8 bits, lower 4 bit value I am declaring with this nibble. Lower 4 bits of data I am declaring to nibble. So how I am declaring means I am using a continuous assignment statement, assign nibble data of 3 down to 0. Okay. Initial begin, I am declaring data equal to 8 tick binary 1010 double one. So this is for readability, I can use underscore double one double zero. So assign the binary value to this data. After 10 time units, dollar display data equal to percentage b, nibble equal to percentage b, comma data, comma nibble, end and end module. Did you understood this code? Okay. So just select this. So simple. First data I am declaring with 8 bit of data. Nibble I am declaring with 4 bit of data. Lower 4 bits of data I am declaring in the data. I am declaring to nibble, and I am declaring I am assigning the binary value to data. Next I am declaring, I am displaying whatever the data value, nibble value I am displaying. Okay. So select all, copy, and first we will see the in the EDA playground. Okay. EDA playground. So just save this file, run this code. What is the value of data? 1010 double one double zero, no, 8 bit. Nibble is, what is nibble? Double one double zero, 4 bit. Yeah. Okay. Okay. You got in the log file. This one, if you want to run in the EDA playground, sorry, in the Vivado, just go to this. You need to add the sources. Okay. Create the design source. Create the file. What is my file name? Vector underscore data type. Vector underscore data type. I will. Okay. And I need to store the location. The this location. Okay. Okay. Finish. And module name also same I am giving. Yes. Hmm. What? We need to go to simulation and we need to set a stop module. Yeah. So copy and paste. Save this file and go to the simulation and right click, set as stop module. Yeah, set as stop. That simulation sources you need to set as stop. Run simulation, run behavioral simulation. What is the value of data? 1010 double one double zero, 8 bit. Nibble is the lower 4 bit, double one double zero. Okay. You can see in the simulation sources also. See here, fit to page. What is my data? It is 1010 double one double zero, no? So it is displaying in terms of what? Hexadecimal. Okay. And nibble equal to double one double zero. If you want to display in binary, so right click, go to radix, select binary. Right click, radix, select binary. Now you see. You got this? The simulation? 1010 double one double zero, and nibble is double one double zero. Okay? Yeah. So this is how, so I'm discarding, I'm not saying. Yeah. So this is how you need to see the output for the vectors. Do you understood any doubts or queries? Okay, okay, okay. So next is vector slicing. Okay, what is vector slicing? We'll see. Okay, vector slicing. Hmm. vector slicing. Okay, vector slicing. So I'm declaring like this: reg 5 down to 0 m. Okay, so this is of how many bits? 0 to 5 means 6 bits, no? Okay, 1 2 3 4 5 6. Okay, so you are storing some values. Let us take this value is 0 1 1 and 1 0 1. Okay, this is index 0 1 2 3 4 and 5 5. Okay, so what is this vector slicing means? mm, so I'm writing module tb. Okay, I'm declaring reg 5 down to 0 m. Okay, I can declare that is reg 1 down to 0 m. Okay, initial begin. Okay, initial begin m. I am declaring with the so value 60 binary 0 triple 1 and 0 1 triple 1 0 1. Okay, end and end module. Okay, if I want to display here I can write the display also. So if I want to display, so dollar display the value of m, the value of m is percentage d comma m, percentage, one second, percentage b. I am giving value of m is percentage b comma m, end and end module. Now tell me what is the value of m. First m equal to what? You will get 6 bits only, 0 1 1 1 0 1. Okay, so this is 1 down to 0 means where is 1 down to 0? 0 to 1, no? 0 1. So I can access this 2 bits also. That is nothing but vector slicing. Okay, suppose if you declare one more variable n, n equal to m of 3 down to 2. 3 down to 2 means how I can access? I can access this 2 bits also. Okay, so 2 bits also. So n becomes what? 1 1. See here, 3 down to 2. Okay, or I can access the MSB bit also. So m of 5. So m of 5 means what? N equal to 0. Yeah. So this is vector slicing. Do you understood vector slicing? Okay, vector slicing. And next, if you consider reg 1 down to 0, a comma b comma c. Okay, so this what are the width of this? Tell me. 1 down to 0 means all the bits are of 2 bit, no? A equal to 2 bit, b equal to 2 bit, and c is also equal to 2 bit. Okay, and one more example, module tb. Okay, module tb, reg 1 down to 0 a semicolon, here I am giving b. Okay, here you will get any compilation error. Hmm. Here what is missing over here? Semicolon is nothing but end of the statement, no? So end of the statement, here data type is missing. Okay, you not declared any data type, no, just you declared only variable. So data type is missing. Okay, so you'll get a it should be your y data type or reg data type. So here data type is missing. So that's why you'll get a compilation error. Okay, and next if you take module example input a comma b and 1 down to 0 C. Okay, and output 2 down to 0, I am giving sum. Okay, uh, is this code will run? Why? Okay, that this way I can declare, but after this, what is there? Semicolon is nothing but end of the statement, no? End of the statement, not data type, end of the statement. So, semicolon should not be used inside the bracket. Okay, semicolon should not be used. Should not be used. Should not be used inside the bracket. Inside the bracket. Okay. So, how to declare? So, module example input a comma b comma 1 down to 0 c comma you need to get output 2 down to 0 sum. After bracket semicolon will be there. Have you understood? Okay. I will add one more page. Okay. Hmm. Next, this is very important. Let us take reg 2 down to 0 a. Okay, reg 2 down to 0 a. We are giving a equal to 6. Okay, internally compiler how it will store? What is the value of 6 in binary? 110. Okay, it will store like this 110. Okay, so it will store, that means it will store like this. This is 110. Okay, 110 it will store. Okay, next, I will declare so reg 2 down to 0 a, and one more variable I will declare reg 2 down to 0 b. Okay, I am giving e equal to 6, and again b equal to minus 6. Okay, and now b how it will store, tell me. Hmm. Yes, yes, 2's, why it is 2's complement? We have sine magnitude 1's complement, that is sine magnitude and 1's complement also there, no? Why only it will store in 2's complement? Mm, 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 mm. What is the reason? What is the reason? In digital, I told you. In digital, I told you. That is very important. Mm. Mainly negative numbers are represented in how many forms? Two, three forms, no? Sine magnitude, next one's complement, and two's complement. Okay, this is signed numbers. Signed numbers are negative numbers represented like this. So, what is the reason why you are storing in two's complement? Not remembered. So, you have two representations for zeros, for sine magnitude and one's complement. Okay, two representations for zeros, but for two's complement you have only one representation. Okay, so one representation means, suppose when you want to store sine magnitude or one's complement, there is chance of confusion whether to store minus 0 or plus 0. But if it is 2's complement, you will not get confusion. Why? Because same value you will get. Okay, there I wrote the table. So minus 0 is 0 0 0, plus 0 is 0 0 0, minus 0 is 0 0 0. You got, no? Okay. So that your answer is correct. It will be stored in terms of 2's complement, that is 110. What is 1's complement? 001. Adding 1 to this, you are getting 010. Okay. Now I want to, like, I will give dollar display the value of uh, b, okay, is value of b is percentage d comma b. Then what is the value of b? Anyway, in binary you told that is 010. What is the value of b in decimal? Hmm. So options are decimal. So decimal b is 2 is correct, or decimal and minus 6 is correct. These are the two options. It will display in binary equal to 2 or binary equal to minus 6. 2. Why 2? 2 is correct option. Minus 6 is wrong option. Mhm. Okay. No, not like that. Actually, this will store in terms of value only. So normally, ridge and wide data type are unsigned data types. Unsigned data type. Unsigned data type means it will not store negative values. It will store only positive values only. So that means 010 means this value it will store. So this is in 2's complement only. But whatever this value is there, 010. So b equal to this binary value in decimal means 2. 2 it will store. Okay. So suppose if you want signed means you need to declare like this. Reg signed 1 down to 0 a, like this you need to declare, then it will display so b it will display b equal to minus 6 there. Okay. So what is my conclusion is this reg and wide data type are what type of data types? Are unsigned data types. Unsigned data types. Okay. Unsigned data type. Okay. And next is, have you understood any doubts or queries in this? Okay. Next is integer data type. What is integer data type? Integer data type. This is so this is used for counting. Okay, this is used for counting, and next indexing, and general purpose calculations. General purpose calculations. Okay, general purpose calculations. So here, so integer is how many width of this width of this integer is 32 bit, and this is signed data type. Signed signed data type. Okay, signed data type, and default value is x. X means what? Unknown. X means unknown. Okay. Suppose if you declare integer a equal to 2. Okay. How it will store? It will store in terms of 32 bit. Okay. Okay, this is 0 and 1. Okay, up to so on. So 0, 1, 30, and 31. Okay, so 0 0 like this it will store. Okay, so this is packed data type. What we call packed data type. Packed packet data type means we can't do vector slicing. Okay, we cannot perform vector slicing in this. That means if we want to access only 31, we can't access. Okay, we can't perform vector slicing in integer data type. Okay, integer data type, and we cannot use vectors with integers. We cannot use vectors vectors with integer data type. Okay, data type. So suppose example, if you want to give integer uh, 3 down to 0 a, this is not possible. Do you understood integer data type? Okay, we'll see one example related to integer data type. Okay, so once I will take 10 more minutes, I will complete the data type. Okay, mm, is it fine now? Fine. Okay, yeah. So if you see the integer data type, this is my integer data type. Okay, so if you see this one, so module integer underscore data type integer a initial begin and declaring a equal to what -2 dollar display the value of a is percentage b and percentage 0 d a comma a end and end module. Okay, this is a simple code for declaring the integer data type. Okay, so select all and copy. Okay, and see the output in the eda playground. Okay, what output we will see. First what I will do, I will give 2. Okay, I will give 2. So what is the output? Can you expect the output? 32 bit. It will store the value of a is what 32 bit. Okay, I told you now 0 0 up to so on 1 0. So what is the value of in decimal means 2 2. So it will store in 2. Okay, and if you are giving -2, when you save this file and run this file, it will execute in which form? Negative numbers are represented in, I told you no, 2's complement form. 2's complement form, and it is executing signed data type. No, so negative numbers are represented in negative only. So -2 you are getting. This integer is a signed data type. Have you understood this? Okay. In the VDVAD also, go to the sources. Next, create the file integer underscore data type. Okay, and choose the location. Select OK. Finish. OK. Yes. Okay. One second. Yeah. Uh, so integer data type is created. So select all, copy, and here you paste this. Okay, time scale 2 times is not required. Save this file. Warning. Okay, fine. Warning. Integer, right click, set as top module, and run simulation, run behavior simulation. So what you are getting? 2's complement you are getting, no? 32 bits. Suppose if you change to 2 and relaunch the simulation, what you are getting? That is, one second, error. Okay, yeah, you got the value, no? The value of a is 00102. Okay, yeah, like this you will get the values. Okay, and last data type is uh, time data type. Okay, time data type. What is time data type? It will show the simulation time. Okay, simulation time data type. So time data type, time data type. Okay, time data type. It is easy to track the simulation time. Easy to track the simulation time. Simulation time. Okay, simulation time, and default size is 64 bit, and default value is x, and this is unsigned data type. Time cannot be negative, no. Okay, time cannot be negative, and unsigned, this is unsigned data type. Unsigned data type. Unsigned data type. How we are how we are representing means by using the symbol dollar. Okay, so dollar, when it is starting with dollar means that is system task. Dollar display, dollar monitor, dollar strobe, dollar finish. Okay, that is nothing but system task. Okay, dollar time, it will be represented like this, dollar time. Okay, so dollar display we already seen, no, dollar display, dollar strobe. Okay, dollar strobe, we'll discuss this, dollar finish, dollar stop, like this. You have dollar time also. Okay, format specifier is percentage t. What is format specifier? Percentage t. Okay, next, you have synthesizable constructs and non-synthesizable. So synthesizable constructs. Okay, synthesizable constructs are nothing but which are converting into, what is synthesis? I told you synthesis, no. What is synthesis? Which we can convert into hardware, no. Synthesis, I told you in the first class. Synthesis is gate level netlist. You are converting your code into gate level netlist. Okay, we already seen the data types, no. So wire is synthesizable or non-synthesizable? Wire, wand, war, these all are synthesizable. Synthesizable. Okay, it can be converted into synthesizable. Reg is also synthesizable. Vector is also synthesizable. Integer synthesizable. Okay, uh, so integer synthesizable, and float, these all are synthesizable. Float can't, we can't convert into hardware. Float data type I didn't told, no. Float is one more data type. Float data type. Float data type. It is so float is a keyword. This is used for storing the fractional values, fractional numbers. Okay, it is used for storing the fractional numbers. Uh, uh, so here size is 64 bit. Size is 64 bit, and default value is x. Default value is x, and this is signed data type. Signed data type. Okay, or we can call as real also, float or real. Format specifier is percentage f. What is the format specifier? Percentage f. Okay, percentage f. Okay, so float is non-synthesizable. Float data type is non-synthesizable, and time 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 data type non-synthesizable. Why? Because we are using in the simulation. We can't make the hardware. Okay, initially the procedural block, that is non-synthesizable. That is not data type. That is a procedural block. We call as, we seen in the behavioral modeling. No, you have always block and initial block. Okay, so always block is synthesizable. Okay, but now initial block is non-synthesizable. Okay, so this is about the data types. One more concept, arrays are there. Arrays we'll see in the next class. So is it fine? Dollar display, yeah, dollar display, yeah. Yeah, yeah, yes. Okay, yeah.